All right, let's jump right into this explainer. Today, we're unpacking literally the most critical decision in modern AI design, drawing from some foundational insights by Anasup Consulting. If you're building, managing, or honestly even just interacting with advanced AI systems right now, you know that making an AI smart is really only half the battle. The other half, making absolutely sure it has the right information at the exact right time. Because, let's face it, nobody likes a confidently incorrect AI. That is exactly where Retrieval Augmented Generation, or RAG, comes into play. But as we're going to see, not all RAG systems are created equal.
So, here's a question for you. Is your current AI architecture actually optimized for your specific goals? Or are you just kind of rolling with the default setup because it's what everyone else is doing? We see this happen all the time. Teams rush to integrate AI, but they don't step back to look at the fundamental plumbing that powers the whole thing. In this explainer, we're tackling a crucial debate brought up by Anasup Consulting. Traditional RAG versus vectorless RAG. When exactly do you use what? The answer to this could literally be the difference between a clunky, super expensive AI and a lean, hyper-efficient one.
Section 1. AI Architecture, Intelligence Basis.
Moving right along to Section 2. Architectural Matchup, Traditional RAG Defining the Baseline.
So traditional RAG. This is the baseline solution for AI information retrieval that has basically taken the tech world by storm. When people talk about giving an AI custom data, this is usually what they're talking about. In a traditional setup, your documents are chopped up into smaller pieces, we call those chunks, and they're transformed into mathematical vectors, which then live in a specialized vector database. It's kind of like giving your AI this massive multi-dimensional library catalog. When a user asks the question, the system translates that question into a vector 2 and hunts for the closest mathematical match. It's incredibly powerful for grasping semantic meaning and context, even if the exact keywords don't line up at all. But as you might guess, all that power comes with some pretty heavy and sometimes really expensive requirements.
Which brings us to Section 3, Vectorless RAG, the modern alternative.
Now, unlike the traditional model we just talked about, vectorless RAG strips away all that heavy machinery of vector databases and embedding models. Instead of translating every single thing into complex math, a vectorless approach relies on much more direct retrieval methods. Think of it as just using your existing search indexes, your standard SQL queries, or everyday APIs to fetch the info you need, and then simply handing that text directly to the AI so it can generate an answer. By doing this, you're effectively cutting out a massive layer of computational translation, and let me tell you, that completely changes the game when it comes to efficiency.
All right, Section 4. RAG comparison, the heavyweight matchup.
When you put these two approaches side by side, the trade-offs become super clear. The traditional RAG approach is essentially reading between the lines. It's fantastic for massive piles of unstructured data. Think thousands of messy PDF reports, where you really need the AI to understand the underlying concepts, not just hunt for exact words. But, think about the cost. You've got to maintain a separate vector database, pay for the embedding models, and manage this whole chunking pipeline. It is a heavy lift. The vectorless RAG approach, on the other hand, is incredibly straightforward and lean. It just leverages the systems you already have. So it's lightning fast to set up and way cheaper to run. The catch? It relies heavily on exact matches and the tight structure of your existing data.
So that begs the big question. Which approach actually wins? If you're a developer or a product manager looking at these architectures, which path are you supposed to choose?
Let's get into Section 5. When to use what? Situational superiority.
The reality, as Anasup Consulting brilliantly points out, is that neither of these is objectively better than the other. Instead, they're situationally superior. It's all about your specific needs. If your priority is dealing with unstructured text, say your users are going to ask really vague, conceptual questions about a massive document library, then you definitely need traditional RAG. You need that vector math to connect those semantic dots. But if you need a totally different set of efficiencies, vectorless RAG is your best friend. For example, if you're querying highly structured data, like a customer database where you just need to know exactly how many pairs of shoes were sold last quarter, vectorizing all that is total overkill. It can actually cause the AI to hallucinate. Vectorless RAG just uses a direct database query, grabs that exact number, and feeds it to the AI. It's safer, it's faster, and it's so much cheaper.
To summarize the core takeaways from Anasup Consulting, we really want you to walk away with a clear, actionable framework here. First off, remember that your architecture dictates your AI's capability. Don't let the tail wag the dog. Second, go with traditional RAG when you absolutely need that deep semantic understanding of messy, unstructured data. Third, pivot over to Vectorless RAG when you're dealing with strict, structured data or when low latency and keeping those infrastructure costs down are your main drivers. At the end of the day, you have to match your retrieval strategy to the actual shape of your data and the specific intent of your users.
So, I want you to think about the systems you rely on right now. Are you forcing structured data into a super expensive vector database just because, well, it's the current trend? Or maybe you're expecting a simple keyword search to somehow understand deeply nuanced human context. The smartest AI isn't necessarily the one with the most complex underlying math. It's the one with the architecture perfectly tailored to its job. Based on everything we've unpacked in this explainer today, is your AI architecture holding you back, or is it propelling you forward? Thanks for exploring this with us, and here's hoping this framework helps you build leaner, smarter, and way more effective systems.